We all love taking a shower, but some people seem to spend a lot longer than necessary, leading to increased water usage and heating costs, which isn't kind on the bank balance or the environment. I aim to improve this by implementing a smart shower system, which turns off the water when the allowed time has elapsed. This will be particularly useful for busy parents who don't always remember to ask their children to get out of the shower, or families with teenagers who can average up to 25 minutes each shower. Existing smart systems are expensive, and installation may require removing bathroom tiles, a plumber, and electrician. The user interface can be poor, such as requiring a key to use the system. My system is half the cost and has two components: a solenoid with sensors above the shower head, which turns off the water, measures the flow and temperature and battery levels, and a touchscreen placed outside the shower to allow user control, display water usage and cost estimates, and send email alerts for low battery status or leak detection. Installation is easy. The user removes the shower head and places the solenoid and flow sensor in between, using Teflon tape to ensure a watertight seal. The case is attached above the shower head. The battery pack and sensors are connected to the labelled positions on the PCB and the case sealed. The touchscreen is attached to the wall outside the shower, and the settings screen used to add the regular users, Wi-Fi details and Bluetooth pairing, and customise the allowed number and duration of showers. I recommend that a guest user is added with a temporary password to provide to house guests, but the administrator can also override the system directly. It works as follows. The user will select their name from the touchscreen and enter their PIN to safeguard their shower time from being used by others. The solenoid opens, allowing water to be used. When the water temperature reaches the user's preferred temperature, a beep will sound. The system will beep again when only 1 minute is remaining and finally turn the water off. The system continues to monitor for unexpected water flow in case of solenoid failure or low battery status and informs the administrator by email. Special challenges involved in developing the prototype were introduced by the wet environment, which requires a splash-proof casing and prevents the use of power points within 60 centimeters of the shower, necessitating the solenoid component run on batteries. Strategies to reduce the power consumption were to use a latch solenoid, which only draws current for 20 microseconds when the water is turned on and off, rather than for the entire duration of the shower, use of an Arduino chip rather than a full Arduino or Raspberry Pi, and Bluetooth 4 instead of Bluetooth 2 or Wi-Fi, which significantly reduces current draw when active or transmitting. And the use of sleep modes and wake on Bluetooth and switched rather than a linear power supply dramatically reduced the current draw during the prolonged idle periods. Obtaining an accurate temperature reading is difficult as small changes in the supply voltage have a significant impact on the reading. This is compensated for by using a voltage reference chip which outputs a stable 2.5 volts, and further calibration of the temperature and voltage measurements is possible using the onboard potentiometers. The resistance from the extra tubing from the solenoid and flow sensor reduces the flow rate as water passes through it. My shower head reduced from 7.2 litres per minute to 5.5 litres per minute, which further contributes to reducing water usage. The system can be further extended to run a Mosquito server to allow integration with existing smart home systems or web or mobile applications, and the shower data on the SD card could be sent to a web server to be displayed and help to influence user behaviour. The system offers an opportunity to significantly reduce water and heating costs. By halving shower times to 4 minutes, a family of 4 could save $136 a year on water bills and $285 a year on gas heating costs. The system would pay for itself in 8 months.